Welcome back, everyone. Thanks for tuning in. I'm Tim Martino, Service Manager for Pavement Group, and today we're going to do a walk-around video of our Olympus Mini-Hercules portable pug mill. We're going to cover some safety features today, setup, operations, and maintenance. So stay tuned in, and we'll get you all squared away and ready for production. Okay, guys, so the first thing we're going to want to cover today is safety. Safety. The first thing you want to do is when you get your machine onto your site, you're going to consult your safety manager and you're going to go over your company's safety procedures, lockout and tag out procedures, and we're going to find a nice level surface for this thing and we're going to set it up on our blocks, raise our jack legs. We're going to ensure the whole machine is level and secured on the ground. And we've got a level on the machine so you'll be able to see that it is level. And from there, we will move into setup procedures, hooking up the gen set and getting your machine operational. And we're going to ensure that we have this pug mill completely level. We have a level gauge in the back and we use jack legs and support legs to jack it up and brace it with blocks if need be, if we're on an uneven surface, to ensure that this whole bin and belt system is completely level. If you come to the back of the machine, you'll see that we have a level back there. We use the jack legs to raise it up and the support legs to drop down and pin it into the position that it's going to be in once it's up on its blocks. Right back here, you'll see the level gauge attached to the pug mill itself. You'll see we're sitting nice and level now. We've got it blocked up in the front. We've got our support legs down in the back and in the front. And we are ready to start hooking up our generator. We've got our wheels chalked and our pins are locked in. And right here we've got pins to pin these in. You get them to the proper height, pin them in, and then it's set and safe and level. Safety's huge. We want to make sure that we are completely level so that we are operating in a safe area. We don't have to worry about anything falling down or flipping over. Okay, guys, so at some point you're going to find that you're going to have to do some maintenance on the pug mill. And you need to ensure that you follow your company's lockout and tag out procedures. There's a lot of moving parts. Starting here at the pug mill, we've got shafts spinning and paddles mixing, and back to the conveyor belt. There's a lot of moving parts that can be very dangerous if this thing is not properly locked and tagged out while you start doing maintenance or repairs on the machine. So please refer to your company's policy and follow it accordingly into the lockout and tag out procedures. Okay, guys, so now that we're set up and we're level, now we can move to the next setup procedure, which would be giving the unit power. This runs on 3-phase, 480-volt power. You can get the power from leads from a building or from a portable generator, as we're using here on site. If you're going to use a generator, another thing for safety is know your generator, how to use it, properly trained personnel only, and then you run your leads from your generator right into where they're labeled here. So we've got a ground, lead 1, 2, and 3. Depending on the generator, you may have reverse polarity if you mix 1 and 3. So you would just change 1 to 3 and 3 to 1. We want to make sure that the pug mill rotates from the inside out. And that means that it's running in the forward position and discharging at the end of the pug mill. So what we'll do is we've got these labeled. We know where they match up from our generator, and we'll plug the ground in, lead 1, lead 2, and lead 3 as I got them set up here. So we'll go ahead and plug those in, and then we will show you the next operation in our setup. And here's our ground. Pop that in. These are color-coded to the ones that match up in the panel of the generator. Plug it in, twist it. Lead 3. As I said, some generators are different, so our lead 3 is actually running to lead 1 in the generator box. And like I said, if you consult your generator rental company or the manual for the generator and have trained personnel on it, they'll know exactly how to get the right power in here with the right polarity. Okay, we're all hooked up for power now. We're still locked out. All our fuses and safety switches are off. This breaker's off. Our emergency stop. We have no generator power running right now. So we'll get into the next operation here and part of the setup. All right, guys, so now we're going to fire this generator up so we can get some power to our pug mill. This is a very easy to use generator. You just power it up with a start button. Bring the idle up to run, and then we'll flip our breakers and we'll get power over to our pug mill. Okay, I've now got 480 volts. Flip my breakers on. Now we've got power over to the plug mill, to the main power box. Now, in order to transfer the power from the leads into the plug mill, we've got to turn our main breaker on. We also need to ensure that because of our lockout and tagout procedures on startup, all of our e-stops are now pulled out. So that was pushed in, we just twist it, it pops out, and there's another one on the other side that will go ahead and pop that out, and then we'll get into the operations of the controls. So what we've got here, guys, is our setup instructions. We've got our operator manual that comes with the unit and the keys to open up the cabinets, which are secured in there. This will give you operating instructions, basic maintenance intervals, and some of the wiring diagrams that you'll need to diagnose any potential problems. As you can see in here, it's a nice full color printed out. It's got your serial number in there to match. And you can just go through everything that you need in operations and maintenance schedules for the computer monitor, the asphalt pump, and everything that needs to be covered. You also see a Milwaukee drill here. We'll get into that later. That's going to be part of raising and lowering the machine to make it level. This will be included with the machine, so every new pug mill gets a brand new Milwaukee drill that's used for raising and lowering it. Makes it quick and easy. So now that we've got power into the unit, we've assured that all our e-stops are pulled out. We can now open up our cabinets. Okay, you'll see this is the main control panel. We've got our Danfoss monitor here, our controls for the pug mill, the collecting conveyor, the speed to move it up and down, our water pump and our asphalt pump. And then you got another cabinet here, which holds the Isomag water meter. This is what sends the signal to the Danfoss monitor. Once water is flowing through in this direction and going into the pug mill through these pipes, this Isomag sends a signal and works in parallel with the Danfoss monitor. So the flow rate coming through here will be displayed on the control panel that you're actually monitoring while you're making mix. We've got an in-depth manual on the Isomag as well. That's included with the machine, as well as the Danfoss gets covered in the operations manual, the parts and maintenance. So if there's any kind of adjustments you need to make on the flow meter, the manual is very specific and tells you exactly how to do all that. So if you've got a mechanic on site, they can easily access that manual and put in any kind of new parameters that they need to put in or anything like that. And there's very great instructional videos from Isomag themselves. They help you walk through the process, show you what buttons do what when you press them, and how to set parameters and ensure that your flow meter is working accurately. So now that we've covered that, we've got power to our machine, we can begin operations. And what we'll do is we'll go into the Danfoss monitor. Once this display screen is turned on, okay, we've got power to the unit. We have to hit our green switch here. And now everything is operational. We have full power everywhere, okay? We're going to go into our Danfoss monitor here. And we've got 4 selections on our screen. Our material selection. This is where you will input the opening of the gate and the density of the material that you're using. This is calculated and gives you your overall output once your machine is running. So once the pug mill is mixing and the collecting conveyor starts moving material, it's going to take these 2 settings and do the math for you on this screen and give you your output, which would be in the production screen. So being that our gate opening is 7 and our density is 80 pounds per cubic foot, and we're not running right now, so it's not going to show anything. But once we turn this thing on, it's going to give us our estimated output. So right now, our machine's telling us we've put out 52 tons per hour based on the settings that we've put into this computer. Now you're ready to make some mix. So we're going to move into the control box here, and you'll see the Danfoss monitor that will bring on. Turn the display on. We'll bring main power over. So you'll see our introduction screen. You click enter to get into the main production screen here, and that'll bring up the 4 options that you have for screens here. You can see that you've got memory. This is how many hours have been through how many tons have been run through the machine, how many hours it's been operational, the total hours on it, how much water has been run through it, and how much asphalt has been run through it. We go back a screen. Our calibration, it's 100% factory calibrated and ready to go to work as soon as you get it. Our production screen shows what our output is. If we're adding water or asphalt into the pug mill with our dry material, how many gallons per minute are going into the pug mill? You'll see that there's a gate opening, there's a tons per hour, and there's an RPM. The RPM is the belt speed on the collecting conveyor. The opening is the bin opening on how much material you are allowing to come out of the bin. That's controlled with this wheel that's very easily usable. It's safe because it's out of the way of the belt, and you can easily put in your settings that you have it set to here. To change these settings, we're going to go into our material screen. There are 3 variables here that are very important that we need to put in to get 100% accurate mix. The first one is we need to find the density of our material. So how many pounds per cubic foot does the material weigh? Does it have moisture content? Is it dry? So we get that measurement and we can input it here on the monitor. Right now we're using an 80 pound per cubic foot dense material. Okay, that's just a trial. It's something we had here in the yard. Now we've got our gate opening set to 7. We'll verify that it's set to 7 over there. We're actually at 6.5. We're going to put our setting in here at 6.5 for our opening. Now we've got our 2 main components to our formula. We've got the density and the opening. The third component of this formula for this computer to calculate how many tons per hour are coming out would be how fast the belt is moving in feet per minute, how much material is being carried away and put it into the pug mill. In order for that to pop up, we have to turn the pug mill on first. Excuse me, we'll go back to our production screen. We'll turn the collecting conveyor on and forward. Okay, our speed is all the way down right now and we're running at 24 RPMs, which shows based on the density of the material we're running and the gate opening combined, it gives us our tons per hour. Okay, this is a calculation based on the 2 parameters that we put in. Now here is the actual weight. That's what's actually moving across the scale. When you have material moving, these 2 should be almost matched up. It's saying 31 now because we've got the belt just driving across there empty. Now, once you have material moving across these, you can turn your belt speed up, and this gives your output bigger numbers, right? So if we're moving everything faster, we've got the gate opening as much as it can be. Here's our maximum output at full speed. Now, once we've got material moving, this weigh scale that is underneath the belt will eventually line up here with the tons per hour that you're putting out. And then when you have your actual product come out, you're going to test your first bucket full and make sure that your weight matches the theoretical weight. Okay, so it's going to say you're putting out 82 tons per hour. And you do the calculation, you'll do 1 ton and see how long it takes to get 1 ton out. You'll weigh that out, and if you need to change the efficiency setting on here to plus or minus what matches the weight of the bucket, this can be easily moved up and down with the efficiency setting. So now we're changing how many tons per hour are coming out, right? So we need to verify with the first load what the theoretical weight is that's coming out versus the actual weight on the output. Once we've established that, we're fully calibrated and we're ready to go into production. I'm here with Mark Reeves, and now we're going to go through some FAQs, frequently asked questions. What are you thinking, Mark?
Yeah, hey, my first question is, if somebody's using this control panel for the first time, can you walk us through how the buttons work and which buttons are used? Are they all being used? How do you go back? How do you go forward? Give us the basic navigation, if you would.
So Mark wants to know what is the basic navigation of the Danfoss control monitor. So I will start it right over from scratch, as if we're bringing power in for the first time. We're going to turn our display on.
So the first thing you did, though, you just hit a couple buttons.
Yes,
Walk
I
us
did.
through what you just hit.
So if we have just set the machine up and we plugged our generator in, power is standing by. We need to bring power over to the control panel. Now that I press the on button, the green light comes on and I've got power to my control panel now.
Is that just to the control panel, or is that powering the whole machine?
This powers everything inside of this control panel. So none of this will come on except for the display. I don't need to have this on for the display to come on.
Okay. And so this other button is for what?
So this is off for main power. It's nicely labeled. Main power on. Now we have the ability to turn our pug mill on, our collecting conveyor, our water pump, and our asphalt pump. These will not turn on without the main power being on. Nothing works without the main power. Okay, main power on. Now we've got pug mill, we've got collecting conveyor, we've got water pump and asphalt pump.
Okay, so if we go from the top to the bottom slowly, so what do we got on the top here? We've got
top side, top right, we've got pug mill, moves forward direction only. There's no reason we ever want to move our pug mill backwards. Then we get a stack up of material on the backside, and then we have dangerous conditions where you may have to open the pug mill and shovel it out, and we don't want to do that. Next is our collecting conveyor, forward and reverse. The collecting conveyor cannot come on unless the pug mill is on first. They run in series. So we can now turn our collecting conveyor on, forward or reverse, okay?
So can you explain why it is that the pug mill has to come on first and why it's set up that way?
The pug mill has to come on first because this is wired up in series. It's a safety feature so that you cannot run the collecting conveyor without the pug mill running and accidentally feed a bunch of material into the pug mill and have it be overloaded, which would then present another dangerous situation where you may have to get the pug mill doors open and shovel it out manually. We want to keep that thing closed as much as possible. There's no reason that men should be working around the pug mill with the lids open.
Okay. And then as you bring me down the control panel, what's next?
So we've turned the display on. Here's our introduction screen.
And we've got a forward and reverse IC down there.
Yes. So we'll go enter, center button, bring up the production screen. All right, now going back to the collecting conveyor and the pug mill. We can adjust the speed of the collecting conveyor here with this knob. This is one of our parameters that need to be input to get our production output. Okay, now we're speeded up and we slow it down. Okay, so moving down here to the water pump, you'll see that we have the forward position and a variable speed control here on the water pump, and you can hear that as well when the water pump kicks on. You can turn the speed up and bring it back down, and this actually gets calculated into the Danfoss monitor as well, and you'll be able to see how many gallons per minute you're putting through the water pump. That gets its signal from the Isomag over here. So it won't show anything right now if we turn it on because there's no water actually flowing through here. So the Isomag's not picking anything up and sending it to the Danfoss monitor. But once we have water running through there, it picks up here, sends the signal here, and gives you your output on gallons per minute in water.
Now, Tim, I see we have an asphalt pump as well.
We have an asphalt pump as well. This has forward and reverse functions and variable speed. Up to 60 gallons per minute of asphalt can be pumped in. Okay, and the asphalt pump here is a Viking 8K 124A, and it's a 60 gallon per minute pump, and it's a gear driven pump. Electrically driven motor. Then you'll see we have variable speeds, forward and reverse. Reverse is used to take the asphalt back out of the lines and purge it clean after your operations. So you can put the pump in reverse, get any asphalt that's remaining in the lines or maybe sitting in the bottom of the tank, suck it all back out, and then it's clean and ready for the next use.
I assume that, Tim, I assume there's some sort of clean out procedure for asphalt.
There would be a
solvent through it or something.
clean out procedure for liquid asphalt. Most of the time you would run solvent through it. So with this system, you could actually hook up a solvent line and suck it through the asphalt line system and let it spray out of the spray bars a little bit. And that would clean out the system just like any other asphalt machine that you use solvent to clear it out.
So Tim, my understanding with some of our customers is that they basically put a catch basin underneath the backside to catch the solvent on the way out, right?
So that makes perfect sense. So you want to be environmentally friendly, of course. So if you're going to run solvent through the asphalt pump to clean that out and have it ready for use next time, all it's going to do is spray into the pug mill here. And yeah, a lot of our customers are using a little catch basin to cover this exit here. They'll catch the solvent and then it can be reused at a later date to flush the system out again.
Well, Tim, I've got some questions about the control panel.
Fire away.
One of the things that has always confused people, not with this control panel, but with all of the other control panels out there, is that they can be very complicated. This one is actually very simple to operate. But still, I think it's important for people to understand how simple it is and what the buttons actually do, it makes it a lot easier the first time for them to get in here. So if you could walk through what each of the buttons does and how you actually input by using the various buttons, that'd be great.
Yeah, it's a great point, Mark. A lot of these computer systems are very technical and not very easy to use. We've made it very simple. There are 4 screens that we have access to once we turn this monitor on. The first one would be the material screen. You get into that with this button. Move over to this button,
And
and
how
we've
do you
got,
know you said material screen? Is that
yeah.
noted somewhere?
So as
Okay,
we
you
can
can
see,
do
we've
it.
got material here
Okay.
and a button right below it. When we hit that screen, it brings us to our parameters that we can input manually.
Now let's go to the next screen before we
So
get
I
into
will
the
hit
detail.
escape, bring us out back to this main screen.
Okay.
And now we can go into our production screen with the button underneath that.
Gotcha.
This is what the operator is going to be monitoring the whole time when they're making mix. This is the most important screen. We'll escape out of there again. We've got a calibration screen. This is 100% factory calibrated as soon as it arrives on site. The only time you'll ever have to go in there is if you're having problems with the actual weights meeting the theoretical weights. Then we've got a memory button. This shows how many tons have gone over the belt scale in the life of the machine, how many gallons of asphalt have gone through the pump, how many gallons of water have gone through the water pump, total tons that have passed through the machine, and total hours on the machine. Okay, the total in asphalt and total in water are non-resettable. Those are locked in, and the same with the asphalt overall life. But if you hit the reset button here, you can reset that day's batch. Okay, and you'll go back down to 0 settings.
Okay, so hang on 1 second. So if I got it right, you're saying the green, I see there's a green box around that field, 662.
That's correct.
Show me how to move that up and down.
With these arrows here on this cursor,
It's the center
up and down,
Okay.
we go to our next one, okay?
So go ahead, let's reset the
So we're going to
forward
reset
belt
the
scale
water that's going through here, okay?
You have to hold it or you just press it once?
It is.
It's like you have to hold
It's like a 2-second press to reset it. Okay, so they want to make sure that you didn't accidentally do it. You got to actually hold it there for like 2 seconds for it to reset.
Got it.
All right.
Meanwhile, it's going to maintain the lifetime totals.
Now the lifetime of everything that's gone through this for material, asphalt, and water, those are not resettable.
Perfect.
Same as the hours
Which
for the
is
machine.
what you want.
It's
Like
what
a
you
car,
want.
you want to know how many
It's just
miles
like
you
an
got.
odometer, trip A, trip B.
Okay.
The overall is always stored there, but you can change that day.
All right, so I'm not the smartest guy, so let's go back and show me. This is the first time I've used the machine. Let's suppose I want to make mix. So show me the 2 variables that I put in and how to put those up.
So if you're the operator and you want to make mix this day, the first thing we got to do is go to our material screen and put in our parameters. What is the density of the material that we're using today? It could be different every day. It could
Now,
be.
I don't know the density, but what you're saying, though, is if it's rock versus sand, obviously the density is different, right?
It is. That's correct. If it's moist and versus if it's dry, it changes the density. The density is how much does a cubic foot of material weigh.
Okay.
That's where the density comes from.
In this Mini-Hercules is obviously a 1-bin system, so therefore we only have 1 field to input density.
That's correct. So versus our bigger machines that may have 3 or 4 bins, the density, the product that is in each bin would be able to change the density. Okay, so you could run 3 different materials out of 3 different bins.
Got it. So we got a 3-bin. We're using 3 different products. Then obviously we'd have a different density for each product. And we'd have 3 columns here instead of 1.
That is correct. There would actually be, it would be bin 1, bin 2, bin 3 with all these same parameters here. It would just have 2 other of this row here. Okay.
So now in this case, we entered our density. Go ahead and show me how you do that.
So let's move our cursor down. Sorry. To move in between these settings, we've got to click over, okay? Because pressing up and down changes that parameter.
I see.
All right. So now we'll say it's 77. All right.
77 it is.
Okay, that's in. That's locked in. Now, if we move to the right arrow, all right.
Now in the efficiency.
We're on the efficiency setting. We can come back to that. Yep. That's correct. So there's 3 parameters here you can change. Now, the gate opening.
Let's talk about that.
We've got to talk about the gate opening because that's what's allowing the material to come out of the bin.
So let me just ask you, let's suppose I'm making cold patch. I've got my own liquid. I'm ready to make it. I want to make as much as I can. I would assume that my gate needs to be as open as possible. Is that correct?
That is correct, right. And this gate opening is maxed out at 6.5 inches.
All right, show me how to do that on the wheel over here, if you would.
So now our gate opening is easily changed with the pull of a pin. And this wheel that's outside, we don't have to worry about putting a guy up in there, anything like that. It's very safe from out here. And all we do is turn the wheel, and we can see we've got a needle there, and it matches up with the marks on the ruler, and that's how many inches the gate is open. Okay?
Now, let me ask you this, Tim. I see that, it's a little bit difficult to see from the side. It's not perfect, but you mentioned something earlier about you can turn it all the way and then count the number of holes here.
Well, that's correct. So each one of these holes represents a ½ inch on that ruler. So if we're here at 0,
Yep.
Now it's not actually at 0 because we don't want it to rub on the belt and destroy the belt, right? So it's actually a ½ inch to start out at, right? And then each hole here lined up with the hole is a ½ inch increment. So now I've moved one, I'm at 1 inch now, okay? And that matches right up on the needle there.
Now, Tim, didn't I say something about I want to make a lot of mix?
That's right. So if you want to make a lot of mix, we're going to crank this thing all the way open, okay? Maximum capacity of letting material out of the bin and onto the belt.
Okay, this is where earlier you said we've got a 7 up there, but it's really 6.5
That's
inches.
right. So it's a ruler, and it goes all the way to 7, kind of like a car speedometer goes to 150 miles an hour, but it only goes 120 or whatever.
And so you've input 6.5
So I manually will input what my opening is. So I've set it over there with the wheel. Now I need to put that setting into here.
And so opening it's actually the iron is inches. That's opening in inches, and that's 6.5 inches.
That's 6.5 inches.
Which is going to allow the maximum flow through the gate. And then I'm assuming the only other thing is how fast you want to run your belt.
Well, that's just it. That is the third phase of the formula, is how much material is coming out and how fast it's moving across that belt into the Pugmill. All right. So now that we've got our main 2 parameters set, our density and our gate opening, we're going to exit the material screen, and now we're going to go into production. Now you'll see that there's the opening that we set before. The tons per hour, that's zeroed out, and the RPMs are zeroed out.
If it's zeroed out, why does it say 4?
Well, there is weight that has gone across the weigh scale. So this is an actual weight. And once that weigh scale sends a signal and there's electricity stored in this, we're still holding on to that 4 tons per hour. Once I move this thing, that's going to clear out, okay?
So it'll reset itself.
It'll reset itself. Now, if you're not getting actual numbers that are matching your theoretical numbers, there may be a time where we'll have to have you go into the rice lake controller to calibrate that. And we will get into a video that shows you exactly how to zero out the scale for the rice lakes and make sure that these numbers are zeroed out before you're making mix. So this is just from a previous batch. It's residual that is still sitting in the system.
Okay, so I guess now we need to adjust our belt speed, right?
So that's correct. Now, as we said before, we need to turn this on in order. We have to start with the Pugmill, and then we can turn our collecting conveyor on. Our collecting conveyor has a minimum speed of 24 RPMs. Based on that slow speed right now. So here's the RPMs. That's the belt speed, 24 rotations per minute. If you look to the back of the machine here, there's a speed sensor right here on the end of the belt, and that's what's sending the signal for the RPMs to that Danfoss monitor. This is the Rice Lakes speed sensor for the belt, and that ties in with the weigh scale as well, which is right up in the front.
While we're here, can you just quickly show me where is my sensor that's measuring belt weight? Is that up front?
So that is up front. We're looking for the weigh scale. There's a bridge right here, okay? There's a suspending bridge system, and right in there is a little sensor.
Okay, I see it.
And that's what's giving you the readout for the weight that's passing over that portion of the scale.
Okay, so let's go back to here.
So now that we've got our inputs in, we're 6.5, we know our density, it's automatically calculating the tons per hour that are theoretically coming through the machine. This is a theoretical readout. In order to match this theoretical to your actual numbers coming out, we need to weigh 1 bucket. We'll put a bucket of material through, crank up the speed, and get the output that it's saying theoretically, and we will make sure that it's matched. If we don't match, that's where we will jump into our efficiency settings, where we can change it up or down to match the actual weight coming out.
So my understanding, so the efficiency is because over time things begin to wear out and perhaps the pumps operate or things operate at a slightly different speed.
That's correct.
Is that the idea behind
that is the exact idea behind that. That's correct.
It's also possible that maybe perhaps the calibration, as you said, is theoretical.
It is.
But it's off just a little bit. So efficiency means adjustment?
Efficiency means adjustment in this case, exactly. So if our numbers aren't exactly matched up theoretical to actual weight, that's where we can just come in here we'll go back to our material screen and we can play with the efficiency. Okay, and that's going to change. All right, if we're calling for 47 tons per hour, if we're only putting out 43, and we change the efficiency setting now with the down arrow. All right, we're only putting out 43. Look, we had to go down to 92% efficiency, but now we're reading out exactly what it came out on that first batch of material.
I think some people could be confused by the word efficiency. So again, it's important for them to understand that really it just means adjustment.
Efficiency stands for adjustment. It's an adjustment setting to make your theoretical weight match your actual weight.
Perfect. Great. So does that pretty much sum up everything here related to the Danfoss?
That pretty much sums it up. So if you're the operator, you're always going to be in the production screen. You put in your settings for the day. You know, you're running that same material, you know, and then we can crank up the speed. You know, now we're getting better output, and it's calling for 73. But now we want to add some asphalt, you know, so we can turn the asphalt pump on, and that's going to give us how many gallons per minute based on your company's formula of how much liquid asphalt goes into the mix.
Yep.
We can get it in gallons per minute.
Is that also a theoretical right there?
No, that is an actual, so that pump over there, the Viking K124A, that has a gear-driven pump with a proximity sensor, and that's the pump speed, and that's the maximum output of that pump is 60 gallons per minute.
So whether you're running material through the pump or not,
you're going to see the output because it's a gear pump with a proximity sensor versus the water pump. It's getting its signal from the isomag, so there actually has to be, there's nothing running through. It's not going to see anything. That's correct. But the asphalt pump, that's maxed out. Like that's as fast as it's ever. No matter what liquid's running through there, it's pumping at 59 gallons per minute. That is an actual reading of what the pump is moving at. And we can control that speed here. The only reason, now you can change the speed of the water pump now, but it's not going to read anything because there's nothing flowing through the flow meter.
Right.
And it's not going to get the signal that it's looking for.
The flow meter needs to see water.
The flow meter needs to see water. That's correct. Yep.
Anything else about this control panel that we need to know?
That's everything. It's very simple. Like I said, we've made it very simple to use. Very few parameters that you have to put in there to make your mix. So we made it very user-friendly and for operators to have very easy time using it.
So we've got basically what, waterproof case.
We've got a waterproof box, keeps anything out of there. Locks with a key that's provided. It comes with the machine. We have spares on hand.
It's a standard electrician key.
It is. It's just one of these guys. Yep.
Great.
Okay, same thing for this panel. It's the same one for the isomag, and it's the same one for the main control panel with the power coming in.
Okay. And as you said earlier, I think it's important for people to know.
One key to rule them all.
One key for all. The isomag also, that there's great videos and...
There are great operational videos on YouTube from isomag and isoil. Your machine will come with an operations manual, how to change parameters and everything you need to know about that isomag. Very complex, fancy system, but still all the instructions are there and it's very easy to understand once you read through it.
Thanks, Steph.
Hey, thanks again, guys. Thanks for the questions, Mark. If you ever have an emergency, we got to shut this thing down now. Okay, you hit a button. We got one on each side. Automatically shuts down the whole system. All right, so if you're going to go ahead and use your water pump and your water supply is anywhere underneath this pipe, then you're going to have to prime the system. We've got a quick release cam lock here. If your hose is running into a pond or a tote and it's below the water line here, all you've got to do is fill this up while it's running, get it primed, and then shut your valve to lock it in, and it'll stay primed. If your water source is above this pipe, you don't have to worry about priming it. Gravity will be your friend, and the water will start flowing into the pump before you ever start pumping it.
Hey, Tim, I got to ask, because some people have, obviously people that are buying these machines have most likely used water pumps many times, but for somebody that's never used a water pump, how do you prime it? How much water do you need to put in through the cam lock fitting here to get it primed?
Well, you'll hear it surge. So when your pump is running and you've got your hose into a water source, like a pond or a tote, okay, and you're spinning this pump and nothing's pumping through it, I've got no water, and you're wondering why, it's because there's an air pocket in there. Okay, now we need to take this water bucket, and it's very simple. We got 5 gallons of water here. I'm going to close my valve, and I'm just going to fill it up until it's full. All right, and this is going to start the process of priming this pump with water.
Tim, that's some great looking water you're using there, by the way.
This is gray water because it's got some of our environmentally friendly soy-based Z-release in it. It's what we use for asphalt removal, or when we're winterizing a machine, we'll put some of our Z-release into the line so that nothing freezes up.
We're going to talk about that today, too.
We will talk about that today as well. So now we're full up here to the cap. We've got our hose into our water source, and we start spinning our pump, and we'll be able to hear it physically prime up and start sucking water, and then we can open our valve and let the water come in. Now, this just came out because I filled up the pump. But yes, so that we know we're primed. We've got our water in there. Right? So, a gallon, maybe? Yeah, about maybe a gallon or two just to get it up to the rim. Primes the pump while it's running, and then it's good to go. Once you're primed, as long as you close this valve when you stop running the pump, your prime will stay there. It'll stay primed. Very easy.
Tim, let's talk about the asphalt pump. Now, does this need to be primed as well?
Well, the asphalt pump's different. It's not a centrifugal pump. So the water pump spins on almost like a turbine, centrifugal force, and it needs to have that priming action. This is a direct drive gear pump. So it's coupled up to this electric motor here. And as soon as you put a hose up to it and lock it in and open the valve, and you turn that pump on, you've got suction right away. If it's so strong, it'll even pump air. You don't have to prime this from the top. As soon as you hook it up, it's drawing whatever material you have hooked up to it. And that's the difference between the centrifugal pump and the direct drive gear pump.
I think this is probably a great time to talk about our own user error, where we had some water in the system at the end of the season. So let's go over that, because obviously nobody wants to start up the year and find out that they've got a broken pipe.
That's a really important note, Mark. If this thing's going to be sitting for any amount of time and you're in a state where it gets cold, below freezing, and you've had water passing through here at all, if you don't purge these lines out and put some kind of solvent-based material in there and water somehow gets trapped in the system, if these valves are closed, you would be amazed on how quickly and easily ice can expand and crack the plumbing. You can have valves crack, you can have pressure relief valves crack in here, or you can even have pump housings crack because they're all made out of cast iron, right? So if the ice gets in there or the water gets in there and it freezes, it's almost guaranteed to crack it somewhere. And you'll run into all kinds of problems. You'll have to rebuild pumps or order new ones and pay a bunch of money for expensive parts. This stuff is not cheap. It's very well built, but if it's not properly maintained, it will break.
Tim, what do you run through your system at the end of the season, or if it's colder weather on a daily basis? You know it's empty, but then again, maybe there's still some water in there, and that's what happened. I think in our case, what would you put through the system? What do you recommend?
So, any kind of oil, really, even vegetable oil, okay? Soy-based oil, olive oil, diesel fuel, okay? But you want to be environmentally friendly. As long as you're going to catch this stuff out after the season, sure, put some diesel fuel in there. It's just going to eliminate the chance of the water freezing and expanding. A lot of expensive components, this Isomag flow meter. If there's water trapped in this system, it could expand and just blow out the flow meter. Same thing with the pump. So we want to put some kind of agent in there, whether it be an oil or a fuel source, something that's going to lubricate the system rather than let it freeze. You'll also see that we've got a pressure gauge here on the output side of the asphalt pump. You'll know if this thing starts building pressure that you're not pumping material anymore. You got a clog somewhere. So it's a good thing to have on hand for safety. Let you know that your asphalt's flowing.
So Tim, now I want to tension my belts. Let's just suppose I know it's factory set,
It
right?
is, yes, but there's always going to be maintenance involved. So if you've run material over this thing for a while, chances are you put weight on the belt and it's running over all these rollers and pulleys, it's going to stretch out a little bit over time. You're going to have to retension the belt. It's very easy to do. Back here, we've got two tensioners, right? These bolts lock in together, and this rod here gives you the tension on the belt. Just like a motorcycle wheel, we want to do even tension. So if you're going to come out here, unlock the first bolt and tension down with the second bolt, I want to do half a turn to one turn at a time, evenly on each side. I don't want to get this thing shifted and tighter on one side than the other, because then we're going to have problems with tracking. So we want to tighten each side evenly by a half turn at a time.
So probably tension's not going to be the issue because everything's factory set. But I could see, we have seen on our bigger machines, our cold feed bins and our bigger Pugmill systems where we've got 2, 3 fans with multiple belts, and sometimes there is some adjustment needed where the belt does tend to, I should say tend to, but it tracks over. So walk people through that. How do
It
you
does
adjust
track. So they can set this at the factory with an empty belt and get it to track perfectly. As soon as you add another variable in there by putting material over the belt, from whether it be 1, 2, or 3 bins, you're changing the tension that's on that belt. So if there's material running across it and it's not tracking correctly, you just need to make a fine little adjustment with the tensioners. So if it's tracking to the left, then we need to take it up on the right side and tension that side. And it'll bring it back to the right-hand side, and you'll be running nice and centered again.
So what you're saying is I might need to adjust one, a quarter turn, a half turn, bring these two out. Obviously, it's going to push or pull against the tensioner, which is this blue apparatus that you see
That's your
here,
bearing. Yes,
right?
that's correct.
Without moving the other side.
That's
So,
right.
if I wanted to move the belt to the right, over a little bit to the right, I'm assuming that I need to do I bring this side out or do I bring this side in?
You need to tension the side that you want to bring it to. So you'll make the right side tighter. It'll bring it back and it'll pull it over to that side.
Got it. Okay, that's simple enough.
Yes. We are not sponsored by Milwaukee, but it's a good product.
All right, so I have to ask you, Tim, because people are going to want to know, it's not every day that you buy a machine and you get a really nice drill with it. So tell us a little bit about what you came up with and what we're doing with this drill. Why is this part of the system?
Well, you know, I don't like to cut corners or anything, but I do like to work smarter and not harder. So these jacks for this machine came with manual handles, and there's 4 of them, and it's a pretty big, heavy machine. I mean, it can be pulled around by a pickup truck, but it's still got some weight to it, right? So rather than kill myself and try to crank each one of these up by hand and level it out, and now I got to go over there, and then I got to go to the back corner, and I'm cranking them by hand, and it's really hard, and I'm struggling. I said, you know what? Why don't we just cut those rods right off of there and weld a nut onto the end of it, and we'll make it so that we can use a drill.
Now, here's the thing. I had heard a little story here about the number of drills that you went through to find one that would do the job.
Well, that's just it. I mean, this Milwaukee's got like 1,200 inch-pounds of torque. And I've bought Harbor Freight drills, and I've bought Home Depot drills, and Ryobi and Craftsman. And honestly, I'm a Snap-on guy myself, but this Milwaukee drill is just ridiculous. It's got so much torque. Like, if you're not careful, it can hurt you. That's why it's got this lever on it. You get a real good, strong grip. And then we can easily bring the jack legs up and down on this thing without having to kill ourselves. You know, so I'll bring this one up. I'll spin it slowly. Spin it slowly because, right, we're going to start off real slow because if it's bottomed out, you'll get a really big jerk on it. So we'll go nice and slow. All right, it's moving. Now I can bring the jack leg up. Okay, I want to watch for my pin so I don't bring it up too far and have it bottom out. And I'll show you what the bad result of this could be if you bottom out. You'll see my hand here.
Yeah, so
okay, that's strong.
Take some teeth out,
that could hurt you. Yeah, so you have to be careful. All right, now I'm going to go back down. And you'll see, I didn't have to crank this by hand. I'm going nice and easy. So we came up with the Milwaukee drill. It's great. It comes in a whole kit. It's got 2 batteries. It comes with a charger. These lithium-ion batteries show you how much charge is on the battery. All right, and these are for the M18. And it's just a great little drill. I mean, I don't want to talk it up too much, but
let me stand down here so we can just see it come up off the ground.
Absolutely. Let me make sure that I've got 1, 2, 3, 4. I believe I can get another adjustment out of this and bring it down to the 5th hole. Let's see. All right, now I'll have full extension on this leg, so when I bring it and raise it up, you'll be able to see this rear.
Let's see it happen.
Here we go. Nice and easy. Once this little jack is fully extended, it matches up to the full extension hole on the jack leg here, the landing leg.
I understand too that these holes now run every 3 inches.
Those holes are now set for every 3 inches, so we have more room for adjustment and different surfaces to make it level. I mean, you can't really beat it It makes it so much easier, and it's a lot smarter to do. Not only is there enough power to level it up and level it back down if you need to, but being that the kit comes with a charger and 2 batteries, and our machine has this auxiliary charging port here for a 110 volt outlet. While the machine's running, you can plug your charger in right here in the outlet and charge your batteries. This charger is good for a cell phone or a laptop. The only thing it's not good for is like a pressure washer, or if you're going to put in some kind of anything over 20 amps that requires that much voltage and electricity, it's gonna pop a breaker inside of the main panel. Small devices like chargers, laptop charger, cell phone charger, Milwaukee drill charger, no problem.
And that's this right here, right? This
Right here, we got a 110 volt outlet, just like in your house.
And we've got 2 outlets there, so your cell phone and a laptop.
You can even plug a lamp in there. We've got a portable Pugmill here. We can bring this thing down the road with a pickup truck, F-150, F-250. It's got a hitch extension here. That just helps with maneuvering it. But if this thing were to be shipped in a container, it's designed to fit inside of a standard cargo shipping container. 20 footer? So that would be a 20-footer. So this thing is under 20 feet long. When you take this hitch off, this hitch extension unbolts with 18 bolts, comes off. You can store it alongside of the machine, put the whole thing inside of a container, and we can ship them all over the world.
Very nice. So let's talk about what we got up front here.
We got a standard 3-inch pintle ring here, adjustable mounting positions for your truck. 12-volt breakaway system. This has its own battery. And
where's the battery for this?
So when we follow this down, you look underneath the machine here, our breakaway system is right up underneath the main deck, along with our power unit. So the black box there to the right of the white box, that's our 12-volt breakaway system. It has its own battery contained in it. So if for some reason the electricity failed from your truck to the power plug of this unit, you would still have electric brakes in case of an emergency.
So it looks like we got an easy hookup. What do we got here?
So we got a quick disconnect here for our trailer plug. So that plugs into this. Okay. And then your standard plug will come with your machine to match your truck. So it's normally a 7-way flat RV style, but there are many different ones out there. People have many different kinds of plugs in their trucks. So you'll just order the one that you need for your truck, and it'll come as an extension.
Easy enough. And I see we got some heavy-duty chains here as well.
And that's correct.
Zip tied up. Perfect.
These are just here for transport. Unzip these when you get it, and safely hook those up to the rings of your truck.
Tim, tell me a little bit about these really cool extensions on the bin. I really like it. I've only seen it on the Mini-Hercules, and obviously customers like it. Let's talk about it.
Yeah, absolutely. So the single bin system, this features fold down doors here. So this bin can fold up and extend the capacity of the bin itself. So sitting as it is, we've got a 4 cubic yard capacity, and we meet the height requirements for U.S. roadways. So we can drive down the road legally. We don't have to worry about low bridges or anything like that, any kind of DOT requirements.
Wait, let me interrupt you. So the bin, you're always going to transport it with these extensions down. Correct?
That's correct. Absolutely,
and I'm
yes.
assuming we do not require any permits or anything?
We do not. We are well under DOT standard for operating on the road without a heavy-duty license or anything like that, okay? So like I said, we can pull this down the road with our pickup truck. Now, once we fold these up and they lock into position with these, take a couple of these wing nuts out, a couple of bolts that are in there for storage, and we can fold these up and they bolt back together in the up position. We've increased the capacity of our bin. Now we're at 7.3 cubic yards.
So we're going to go
from 4 to 7.3, yes, just by folding up the doors. Now you can fold up 3 of them, and if you have a small machine like our skid steer here, and you can't reach over the top, then you can load from one side with this side being down, the other 3 up. You won't get the full capacity, but you'll be able to get more capacity than just the standard 4 yards with all of them down.
So how many guys does it take? Does it take a couple guys to lift them up and fit them together?
A single guy can do it. It's easier to have another set of hands, usually safer. You got a guy up on a ladder. Yeah. It's usually good to have backup. So 2 guys, I would say, is preferred. It is doable with 1 guy.
Is there an order in which these fold up when you're pinning it in place?
There's no specific order. You just unpin all of them, and then you'll see as you fold. I usually, when I do it, I do one front and one side at a time, so I can meet the corner and pin it with 1 bolt, and then I can lock it in all by myself.
And I assume you get on a ladder, preferably?
You get on a ladder, make sure that it's safe up there, and you just fold them up, and you lock them in with the wing nuts that are provided. Okay. Pretty straightforward, pretty simple to do. They're not very heavy, but they are thick enough to hold material. and not get destroyed if you accidentally bump into them or something. They're pretty thick. All right, now we're going to talk about the maintenance portion of our belt and our scraper. What do you think, Mark? Does this look pretty straightforward to you?
You know, to me, it looks like it's nicely lined up. I mean, I don't know about the tension. Maybe there's a way you can quickly check tension. Yeah, just give
Yeah,
it a good
it's
tug.
pretty tight. Now, if it was loose, this thing would fold all the way back to here.
Okay.
In order to change that setting, you loosen these two set screws,
Okay.
and then you use a wrench on this big bolt once these two are loose. Okay, and we can pull the tension away from the belt. We can clear out any debris that's in there. We can scrape our belt scraper off and make sure that's clean. And then we can just put the tension back on it and lock it in with the two set screws.
So again, if I put a big wrench on this and I pull it back, I'm assuming that the scraper is going to come back with
That's
it.
exactly
So
right.
you're just going to put a little bit of force on it to get it where you want it.
To the exact tension that you want. That's right. I've got it set very nicely so there's no gap here, but it still puts enough tension onto the belt to scrape it clean.
Perfect.
Now for another maintenance standpoint, you'll see that we have Zerk fittings to grease all of our bearings. They're all labeled nicely. As you move around the machine, you will see where the grease fittings are labeled. And in comparison to our other units, these ones are individual to the bearings. On our bigger units, we will have a centralized greasing hub. It's basically a manifold where the grease fittings for 4 separate bearings will be all in a row, 1, 2, 3, 4. You stand in one spot and grease them up. This is a much smaller machine, so we've only got 5 or 6 grease fittings on here. Greasing point here, Zerk fitting, put your grease gun up to it, and it's the same on the other side. So we've got one here, and we'll go ahead right down the line. Basically, anywhere you're going to see a bearing, here's one here. Grease that bearing, right? We got a greasing point here for the gears that are inside of this box, this oil bath box. Okay, and another replaceable maintenance item is your drive belts. You got a 2-pulley system here with a double belt on them, and we have these readily in stock. I would recommend keeping a set on hand in case one ever went out in the middle of a job. A couple of belts, very inexpensive, very easy to change out.
Yeah, it looks like you just pull the safety cover off here.
You can take the safety cover off, move your adjustment pulley, take the tension off of the belt, remove them, and put the 2 new belts on and tension it back down.
Now, how do you reduce the tension on the belts? What's the process for that?
There it is right there is your setting for your tension. Okay, so as you lower these bolts, the whole drive motor drops down and brings this shaft down with it.
Yep.
That relieves the tension, and then you take your belt off, put the new ones on, and then just tighten these back up. Okay, these ones up here.
Yes.
And that'll bring tension back up on the belt.
You know, Tim, well, hopefully I'm still in earshot here, but we had a customer that wanted to run their belt. Actually, they wanted to run it slower because they needed more torque. Can you explain that? They put a larger pulley at the top for more torque. But if somebody wanted to get more output from their Mini-Hercules, you could do the reverse of that. Couldn't you just put a smaller pulley here, and then that would drive everything quicker?
The easiest way to think about that, Mark, is think of a mountain bike. When you're changing gears, right? You're going from a smaller sprocket to a bigger sprocket. It makes it easier to pedal, so you can get more torque, but you'll get less speed, right? When you want to downshift into a higher gear, you want to go into 6-speed and go down the hill, then you need the smaller pulley, and the rotations become less, but you're moving a greater distance. So you can absolutely change the pulleys out to change the gear reduction on there.
You know, one thing that I do want to say is our box, meaning our Pugmill box, is set up and rated for the maximum output, which turns out to be roughly 80 ton per hour nominal output. But once again, if the box will accept it and you don't have any issues, you could theoretically easily get 100 ton an hour.
That's correct. You could definitely easily achieve that by changing the pulley, and you keep an eye on it, run a couple test batches, and make sure that everything you're putting into the pug mill is being put out. And as long as you don't overload that pug mill, the numbers could be greater than 100 tons per hour. You just have to see what the pug mill can handle, okay? Because that doesn't have the same gear reduction belt pulley setup. It's got a Dodge reducer on it, okay? So that's not just easily swapped out. You'd have to get a whole different reduction.
And I assume some of this is going to be based on density, material, heavier, greater density. It might
moisture content.
So much material through that pug mill.
That's right. That's correct. Yeah. So right now it's set. It's about 80 tons per hour maximum output.
And on the low side, what, 40-ish?
It's about 42. Yeah. Yep.
Okay.
And that's running at the slowest speed. There are parameters that you can change inside these electronic boxes to slow down the belt speed, the RPM. So you could get less output if you wanted. You could get down to, I believe it was 24. So the parameters are all in the manual, and it's very easy to access and understand that if you need to slow the speed down. Okay, so the gearbox for the gears that spin the Pugmill shafts. The box here, this is the gearbox. It's a gear oil bath, so the gears come down to this level. So if we're going to replace the oil, we're going to drain all the old gear oil out. We're going to unplug this plug and put our hose in here, and we're going to undo this little fastener, and we're going to put gear oil into this tank until it starts coming out of here. Once it starts coming out, we know that's where our level is, and the gears inside there are just going to rotate around and dip into that oil and lift it up, and that is enough to cover these gears.
So Tim, this comes from the factory with gear oil.
This is fully ready to go from the factory. They put the exact right amount of gear oil in there and the right specification, which you can find in your manual if you're ever going to change your gear oil out. We'll have that in the manual for you.
Okay, to show everybody where the port is on the bottom there to drain it out. Is that it right there?
Right over on the far end of the tank is a plug. And you pull that plug out, put a catch pan underneath there, and you drain all your old gear oil out.
Okay, great. Perfect. Now, while we're on it, Tim, let's talk about the Dodge reducer. Anything we need to do with the reducer?
So the reducer is belt driven from the motor there, that electric motor. That's our gear reduction. So that's a big heavy duty motor. We need to bring that down a little bit with this Dodge reducer. The Dodge reducer also has gear oil inside of it, bath box. And if you look at your manual, we will give you scheduled maintenance parameters to change that gear oil out as well. You'll do the same thing. You'll drain it from the plug in the bottom. There's a fill port here, and then there's another port right here on the side that you'll take out. Once it starts leaking out of that, that's when you know you're at the correct level of gear oil inside of there.
So the fill port again, is it the one that's got a little blue on it there?
Yes, so we got the fill port here, and then you've got your level port here, so you'll have that cracked open.
And there's a drain down there.
And then there's a drain down there on the bottom.
I see, Tim, we've got a couple of black iron ports coming out the side. What are these for?
Well, those are actually your spray bars for your asphalt and your water pumps. So the lines come up through the other side of the Pugmill, and it is some black iron pipe, and they've got pre-drilled holes in them, and they're about quarter-inch holes, and that's where your material is actually spraying out of. So this passes right through. There's like 16 holes on each bar on the inside, and you spray water or you spray your asphalt directly onto your material as it comes into the Pugmill, and then it all mixes up on the way out.
Tim, let's talk about the Pugmill. So we have some great pictures and videos of our Pugmill, of the inside. Can you talk a little bit about paddle tips in terms of reversibility, Hardox, the liner, the cricket, that kind of thing?
Absolutely. So starting with the design of the Pugmill, you've got an 8-foot Pugmill box here, and inside you've got 2 shafts. On the 2 shafts, we've got 48 paddles in total. We've got a Hardox liner, which is basically hardened steel with a nice coating on it so it wears less.
So when you say a Hardox liner, you're talking about the Hardox being on the bottom of the...
That's correct. So the Hardox is actually a liner that goes on the bottom of the Pugmill itself, and this gives it less wear and tear. So you're not going to actually wear out the liner itself. Hardox will wear out over time, and that's a replaceable item. We carry that in inventory. And the same thing with the 48 paddle tips. They are also chromium, and they're reversible as well. So you can use one side of them until you start to wear them out, and then they're easily unbolted and flipped over, and you can utilize the other side and get that much life out of those as well.
And are they bolt on, bolt off?
They are bolt on, bolt off, yes. And there's 48 of them inside of the Pugmill.
Would there ever be a reason that somebody would need to replace the shafts? I mean, I suppose that a giant piece of steel gets in there.
I've seen some people run rebar accidentally through their Pugmill. If they're scooping stuff up out of piles and it hasn't been screened properly, all kinds of stuff can get in there. Rebar, bricks, and yes, it could damage the shafts over time. You could get a bent shaft, or you could blow out a bearing. And these are all, wear items that are replaceable, and it's pretty easy to do the work, and we have the parts readily available.
And I believe we have an instruction video that we can provide if people want to.
We also can provide an instructional video on how to take the shafts out, replace paddles, or replace bearings.
So we're on the back end of the Pugmill. Obviously, we're up here on a platform. I see that we have here a couple of square openings. What are these for?
Well, this Pugmill comes with a ladder, and if you have it way up in the air and you need access to the platform here, you're going to need a way up. So it comes with a ladder, and the ladder actually stows into these slots and clamps down and secures right like that, and you can climb up and down the side of the
So
machine.
this is a ladder that is currently on the other side.
So you'll see it's here for transport. You can move it to either side, but yes, it's you take it out of its stowaway position. It's for transport right now, and the two hooks up there will actually be pinned into here and locked down.
I understand, Tim, that the Mini-Hercules is pretty much one of a kind when it comes to portability. So tell us a little bit about the portability of the Mini-Hercules.
Yeah, that's right, Mark. This thing can go right down any U.S. road. It's legal width and height, and it's got a panel ring up front. You can hook this up to virtually any size pickup truck, F-150, GMC 1500, F-250. As long as your vehicle can handle the 9,800 pounds weight, then you're good to go down the road with this thing. You don't need any kind of special license or anything.
So, Tim, you were saying 9,800 pounds. What do we got underneath it as far as axles and such?
We've actually got two Dexter 7,500 pound axles, so 14,000 pound capacity overall. We've got electric drum brakes on all four wheels, as you'll see there. Leaf spring setup, real nice smooth ride going down the road.
Got a pintle ring up front.
We have a 3-inch pintle ring standard up front with a hitch extension. If this thing needs to be shipped in a container, you can take the extension off, and it will fit into a standard 20-foot container.
Beautiful. Thanks, Tim.
Absolutely.
So this is a good place for us to look at the bottom of the Pugmill. Tell us what we're looking at. I mean, I see the curves there. Obviously, curves with the shafts.
That's correct. So you'll see those bolts. Those are holding the Hardox liner into the bottom of the Pugmill liner itself. So we've got a liner on top of the bottom of the Pugmill. So that floor that's on the inside of there is a replaceable wear item. It's Hardox steel, and it's meant to withstand the capacity of these abrasive materials that run through here, whether it be lime or asphalt millings, anything like that. It's designed to not wear out as quickly as normal mild steel would.
So what you're telling me is it's pretty easy to, relatively
You can see it right here.
The liner.
This is our, it's like 3/16 steel liner. Yeah. Okay. So this just sits up here inside of the Pugmill, and it's bolted in. So if it ever wears out, all you got to do is unbolt it, order a new liner, and bolt the new one in.
Beautiful. And it looks like from here we can see the paddle tips pretty well, and I can see that these
you
are
can
bolted
see the
in
clearances,
place.
correct.
Yep.
So
these are all chromium plated?
These are all chromium plated, bolted in. You can use both sides of them. So once it wears out here and your clearance isn't moving the material anymore, you unbolt it, flip the paddle around, and now you get twice as long as life out of one paddle.